We're going to start lesson 49 by looking at linear intercepts. So say it gives us a line like so. And we've kind of done this in the past, but it was smaller and easier to read. Say it's a lot, it doesn't really give you anything. You can't tell even where it crosses the y-axis. And it wants us to figure out the equation of this line. Well, we know that the equation of the line is y equals mx plus b is the formula. So in order to find, we can't find b right now. We can't see where it crosses. But we can find the slope. We can find the slope by finding two coordinates on the graph, or on the line on the graph. So two coordinates, for example, would be here at 1, 2, 3, 4, 0, and here, 1, 2, 3, 6. Now the reason I know the reason you're able to see that there are coordinates is because it crosses through at this T, all right? They have to cross evenly through. Like, I can't name what coordinate that is. It'd be a fraction. You want to find whole numbers. So now with these coordinates, what we can do is our slope formula, because we need to find m. So the slope formula was y2 minus y1 over x2 minus x1. So y2 would be 6. We'll call that 6. y1 is 0. x2 is 3. x1 is 4. So therefore our slope would be 6 over negative 1, aka negative 6. Now that we have our slope, we know m, and then we also know at x and y. Since we know this is a coordinate, we know x equals 4 and y equals 0. Kind of weird how I circled that, but x equals 4, y equals 0. So therefore in y equals mx plus b, we know y, m, and x. So we plug it in. Y is 0, m is negative 6, x is 4, and we're trying to find b. So we have 0 equals negative 6 times 4, negative 24, plus b equals 0. Add 24 to both sides, and we find that b equals 24. Therefore, the equation of our line would be y equals negative 6x plus 24. And that's how you do these linear equations, but it's just a little bit longer. You've got to find two coordinates to be able to figure out the slope. Now, the next concept we're going to look at is transversals. We've done this in the past. We know that a transversal is a line that intersects two parallel lines. Well, the truth is they don't have to necessarily be parallel, but intersects two lines. So this is our transversal. Now, since example 49.1 says that lines 1 and 2 are parallel, okay, well that means angles, we have small angles, Z and P would be examples of small angles, and we have big angles, 153 is given to us. The small and big angles are always supplementary. So we know 153 plus angle Z equals 180. So then we subtract 153, and we find that Z would be 24. No, that's not right. 27. Z would be 27. If Z is 27, we know that P also is 27 because they're corresponding angles, and they're both small angles. However, the problem actually wants us to find A and B. So now we're to this triangle here, and I want to isolate this triangle. There is actually a right angle sign in the problem. Forgot to draw it. We have A, B, 7, and we know this is 27 degrees. So what we did a few lessons ago is we talked about solving for right triangles by using sine, cosine, and tangent. So we find B and A using sine, cosine, and tangent, trigonometry, using our angle that we have, 27. So we can say sine of 27 equals opposite B over hypotenuse 7. Okay, that's good. That's going to help us find B. So I punch in my calculator. Well, actually, to get B by itself, we multiply by 7. The 7 goes on the left side of sine, because technically it's 7 times sine of 27. But all you have to do is put in your calculator 7 sine 27, and you get 3.18. 3.18 for B. So we've got B, 3.18. Now we just need to find A. So we'll erase this part. So we already used sine, so we know it's not going to be that. If we're talking about B, well, or sorry, A, we already have B. Well, that would be considered the adjacent to 27. We already know the hypotenuse, and that's a whole number. So which one uses adjacent and hypotenuse? That is ka, if you remember. So ka toa. So therefore, we're going to use cosine of 27. So this is our starting point, equals adjacent A over hypotenuse 7. So then we multiply by 7. Seven cosine 27. 7 cosine 27 is roughly 6.23. And there would be your answers. So it's combining transversals with right angles. Let's look at one more. 49.2, example 49.2. Lines 1 and 2 are parallel once again. Gives us 158 in angle B, and it actually goes ahead and tells us they're congruent, they're corresponding. Well, let's do this mental math. 180 minus 158 is 22. So therefore A is 22. Bring this triangle down. And we need to solve for M and N. M and N. So we do the same thing we did last one. Sine of 22 equals N over 90. Multiply by 90. And 90 sine 22 would be 33.3. M is 33.3. So, N, sorry, degree. N is 33.3, and now we just need to find M. So like we did on the last one, adjacent over hypotenuse cosine 22 equals M over 90. Multiply by the 90. 90 times cosine of 22 should give you 83.7. You could have done Pythagorean theorem, but I prefer that way. I think it's quicker if you are good at the trigonometry. And so those would be your two answers, and that's how you do transversal lines and solving for right triangles.